Okay, for the sake of time, I'm going to start this running now because it's going to take a minute. So, here's my project. It sorts the B-movie script, so not the whole thing, about 2,800 lines or so of it. So up until about here, where it says selection sort, that's just reading in the file. And then we're using a selection sort. So we're going to start at the lowest index, and then we're going to check all higher words in this inner for loop. And we're going to use compare alphabetical to see if the current word is lower than the current word in the inner loop is lower than the word in the outer loop, and if so, we're going to swap them. Yes, and then we keep going. So after that runs at O(n) squared, and so with data this big, it takes a couple of minutes, which is why I started it first. Then we print out the sorted array, and we'll see that eventually. Then this while true loop is just getting, I know don't use while true loops, but this is just getting user input, so we can search for things forever. So it'll get our key, which is what we put in, what we type into the keyboard, and then it will get low and high. Low is 0, and high is the size of our data set, and that's how it starts. And then we binary search, so we pass key low high in, and then in is the sorted array. And then it'll return a -1 if we don't find anything, and if we do find something, then it'll print the index that we found it at. But that'll run a binary search. So here's our binary search. So first thing, if high ever gets lower than low, then that means we didn't find anything, and we'll return a -1. Here we calculate the middle between the high and the low, so the dead middle point, and that's where we're going to check for our value. So if the key equals the value at the middle that we calculated, then we return the middle because we found it. Hooray us! Otherwise, we run it again. So this is recursive, and we're going to pass middle, let's see, as the high. Yeah, so we compare alphabetical. I'll go over that method in a second, to find out whether the middle was lower or higher than we want it to be. If it's higher, then we're going to move the high to the middle by running binary search again and passing middle as the high. Otherwise, other way around, we pass middle as the low, and then that'll slowly just bring us in, or much faster than O(n) squared, bring us in to our value that we're looking for, assuming it's there. And so that runs at O log n. Compare alphabetical. I want to preface this. I made this before we went over ASCII in class. So the way I did it is a little weird. We're going to get alphabetical, which will return an array of integers, and the array of integers represents the place. Each integer in the integer array represents the place in the alphabet of its corresponding character. So we pass get alphabetical a string, and then we create an array of integers, and for each spot in that array of integers, we take the char out of that, we use a for loop to take the char out of that, and then reference it with this static string that I just have sitting up here. That is, A, B, C, D, E, F, G, and then all the special characters tacked on that at the end. And that will return us an integer, which we can use to find the alphabetical order. And then compare alphabetical does so, finds the alphabetical order of two things using these for loops. This runs it O to the n, because it's just regular for loops. And then, that's how we're finding things in alphabetical order. But, alright, speaking of that binary search, we can use it now because we finally got our stuff back. So you can see A's, B's, C, D, G, H, I, K, L, M, N, O, all the way to our special characters. And they're at the back, and then Y and Z eventually. Oh, no Z's. Wow, that's odd. No Z's in this script. But we can look for something. We'll look for the word B. It's at 588. We'll look for Benson. That's the dude's last name. 695. We'll look for and. Found and. Yeah, so that is that working. Thank you very much for watching. I said that as if it was a question. Thank you very much for watching.